What the heck is happening?
What the heck is happening?
Hello and welcome to another episode of our Training Topics and Tech in Nature podcast. Using artificial intelligence to make city planning more sustainable. That is the plan of Infrared City, an Austrian Institute of Technology spin-off. Recently, the young company managed to secure a significant investment. And to talk about the company and the new capital infusion, I now welcome Angelos Chronis, CEO and co-founder of Infrared City. Hello, Angelos. Welcome.
Hello, and thank you for having me.
Yeah, happy to have you. So I just alluded to what Infrared City does, but I probably didn't entirely do it justice. Could you tell us a little bit about what you do?
Definitely. I think you described it very well. Maybe with an intro, I mean, we all know climate change is hitting us hard at this moment. Every month we break a new record of heat and climate extreme events. We need to plan our cities for resilience. So the issue with that is for essentially the architecture, engineering, and construction industry, for the industry that designs and plans and constructs our cities, to understand the impact of climate on our urban environments is not as easy. The reason for that is what we normally need to do is run simulations, complex environmental simulations that are very time consuming, difficult to run. They take a lot of computational effort, and that means that they're not integrated in design. So to give you a very simple example, if I'm an architect and I'm planning a new building or a new part of a city, or I'm a developer, I need to understand the impact that that new development will have on the climate, on the wind, on the sun, on all the different elements of the climate. And the same, of course, if I'm adapting an existing structure. These sort of plans would need simulations, climate simulations, to help me understand this impact. These are very time consuming, very complex, and what Infrared does is it uses AI to make these simulations a lot more accessible. I think the best example is wind simulations. So wind simulations are very time consuming, notoriously difficult, computational fluid dynamics simulations, we call them. And to run a simulation like that, you may need up to 3 days to understand the impact of essentially a new construction on the wind patterns of a certain area of the city. The same simulation result, Infrared can predict with 90% accuracy in a second. And that is really groundbreaking. So that's what it does. It makes climate simulations accessible to everyone involved in our city's planning.
Okay, very exciting. And so, what do you think when you talk about sustainable city development? What does a sustainable city look like to you?
It's a very, very interesting but also very difficult question. Like, to understand sustainability, I'm actually going to remove, let's say, social and economic sustainability out of this question for now, for simplicity.
Sure, yeah.
When we're talking about how do our urban environments interact with the climate, it's a very complex system, right? You have like networks of movement, you have built constructions, energy exchanges between buildings and the environment, between buildings and systems. This is a very, very complex system that each of it is adapted in a different way, and in the end contributes or decarbonization and more sustainable design. The thing is, normally it's very difficult to have an overview of all these different layers. And I think for me, the most difficult part, and the one that we're trying to tackle with Infrared, is to be able to connect all the different aspects of this sort of like design, of this adaptation, to be able to make decisions with impact assessment, like on the spot. So if we take an example, I think that's the easiest way to do this. There's a lot of talk, I live in Vienna, there's a lot of talk here for pedestrianization of different parts of the sort of like central Vienna. And every time you have a project where you say, okay, I want to pedestrianize, let's say, this road, and I want to put some trees on it, and I want to put some benches, you have to understand what will happen if you put the trees over here, if you put the trees over there, if you essentially have new constructions here or there. The problem is that the different consultants, the different sort of like parties that are involved in this discussion are very difficult to sort of like give answers. Like you have to wait for 4 weeks for every simulation, for every analysis to run so that you can understand the impact. Then you can't really have a decision on key design aspects of this adaptation fast. So I think the key to this decision making is to be able to inform the stakeholders of this decision making as quickly and as intuitively as possible. And that's where we're going with infrared.
I see. So that sounds like that would impact a lot of different decisions. So what exactly does your AI do in this process? You mentioned earlier wind simulations, but what exactly does the AI do regarding these simulations? How far does this go?
Yeah. So what currently is done with infrared, as I said, is if you had to run a normal simulation of, let's take the example of the trees on the sort of like on a square. If you have to figure out how the wind moves around these trees and how it will, like how these trees would affect essentially cold winter wind or like nice summer breeze, you'll have to run simulations to essentially look at every meter in that square and essentially understand the impact that your constructions or your adaptations will have. Normally, these simulations would have to be done by an expert. It would have to be done with different sort of like simulation software, etc., and it would take a very long time. What infrared does is it uses deep learning models and predicts the simulation results directly. You don't actually have to do any of the simulations. You go directly to the result. Of course, to do that, we need to have trained AI models with thousands of simulations results that we've already run. So we produce thousands of simulations for different simulation, let's say, models, whether it is like the wind, solar radiation, like sunlight hours. We're going to look at noise. We're going to look at a lot of different topics. And what we do is we run thousands of these simulations and we train models to go directly to the result. And that's essentially in a nutshell what infrared does. Yeah.
Okay, very cool. I was just about to ask you about the training of the AI model. Does that sounds like you basically generate all the data yourself? Do I have that right, or do you get the data from other sources too?
So in most cases, for the simulations that we're currently predicting with infrared, what we are doing is using simulation results that we produce. So essentially, we can have as an input 3D models and urban environments of the whole world, whatever we have as open data for the urban environments, essentially the 3D models of cities, which we use as input. And then we run simulations with industry standard simulation workflows, the simulations you would normally do if you were to do any of these sorts of like projects. And then we feed these simulation results to our models. So yeah, of course, we own the data of the simulation results as well as the trained AI models afterwards.
Okay, very interesting. And just so our listeners can picture this a little better, just how much work your AI actually takes from you, just does for you. How exactly do these simulations work if you have to sort of manually do them? How do you do these simulations?
Yeah, that is a bit of burden. First of all, it's let's take the example of the wind. It's actually one of the most successful things, and we're most well known for that we've done. The example of the wind simulation, it would require, for example, to get a 3D model of the area that you're going to simulate, and then you take that 3D model, you have to mesh it, you have to create, let's say, a 3D digital representation of that model in a sort of like mesh, which is essentially what's used to run equations and solve them linearly so that you can come to a conclusion of how the wind moves. So it would take maybe like, let's say, maybe half a day to mesh and make sure that the mesh is correct. And that, by the way, has to be done by an expert, because if you don't have any knowledge, it's not very easy to do. Then you have to essentially run the simulation. It would take at least a day to run, just runtime. And then you'll have to take that simulation result, you have to visualize or cut planes through it, and then use these planes to run, essentially to demonstrate the results. So the whole process is like, export meshing, run simulation, and then visualization and results querying. It takes normally like not less than 3 days, but it's more than that. Like these simulations normally cost a huge amount of money. I'm not going to call here numbers, but like, if you go to a consultant, you normally do pay a lot for these kinds of simulations. So we're trying to remove all of this burden, the expert, the payment, and the cost of the fees and the simulation, let's say, software that's very, very costly, and also to have it all more accessible from the user perspective. So the user can actually just very quickly see a sort of overview of these results in their software. The other thing that's very interesting with infrared is we're taking a different approach on integration. So instead of like having everybody to come to our own design system, we want to integrate simulation as a service to other CAD software. So it means that if you're already running some CAD software and you're modeling in there, what we want to do is deliver the simulation result directly to you, so that you don't have to actually, have the burden of training yourself in a new software, of exporting and importing data, etc. So we want to connect the simulations directly with leading CAD software. Of what I'm saying, all of us are both of all four co-founders have been involved in teaching and developing such models for quite some time. I've been teaching specifically simulations, integration of simulations for architecture and planning for more than 10 years now, and we've seen the burden. We actually started infrared as a solution to our own problems. So in a way, it came naturally as a sort of like solution, rather than us having to think of what problem to solve.
It sounds like a very big relief. By the way, what is your AI called? Does it have a specific name?
It's currently called infrared. We don't have another name for it.
It's usually good to name the company and the product the same thing.
Yeah.
Okay, great. And it sounds like you have a very promising model here, and investors clearly see it the same way. As I said earlier, you managed to land a pretty sizable investment, right? And can you tell us a little more about that? How much money did you receive and who invested?
Yeah, so we've raised our first pre-seed round. It's specifically 1,025,000. So let's say around a million, and it was led by Exista Science Ventures. Exista is one of the most well-known science ventures in Austria. It led the round, and then we also had investments from 2BX Urban Tech, which is Berlin-based, as well as Heartfelt Capital, Antler, and also a ticket from P3A Holdings, which is also Berlin-based. I think that's the whole sort of like investment team.
Great. Well, congrats to that. And
Thank you very much.
Sure. And then what do you plan to do with all that new fresh capital?
Yeah, for sure. We have a very busy roadmap ahead of us. We aim to put a lot of effort in the development of the technology, in the development of the product. We do have an MVP. We had clients and pilot customers using our MVP, but now it's the time for the first commercial release of infrared. Like, we've spinned off from AIT, and now we're pushing hard on developing as much value as we can. We hope to have a first release of the product in about 6 months to show the whole world what infrared can do, essentially get it out of the sort of like lab and then put it out in the world of the market. And we're aiming to develop mainly in two directions. One is, of course, AI models, like essentially as many sort of like simulation models as we can offer. And also we're developing on top of it a recommendation system, which is essentially using this information to recommend actions to users, actions that could make their designs better, which I think will be a very, very interesting bit to talk about in 6 months. And the other side, and of course, whatever that entails, like the back-end development of all of that and the simulation or software as a service infrastructure. At the same time, we want to focus a lot on integration, as I was saying before, getting our models into CAD systems, into everything that any sort of like user would have to use. And it's not just CAD systems. We have an API. We have other sort of like ways of people accessing infrared, and we want to test a little bit where we can put the most effort in integrating infrared. And not to forget, what we're also trying to build, and we think is crucial in the development of infrared, is a community of users that will lead us to the development of infrared, because we want to develop with our users, not for our users.
I see. Okay. Very interesting. And concerning the use of your algorithm in the long run, just how would that work? Would I input my planned strategy for city planning and the algorithm would sort of make an audit, recommend improvements to me? Or would I basically input what I'm planning to do and it would propose a strategy to me, or both maybe? How would that work in the end?
Both, maybe. So what we want to do with infrared is essentially to really impact the whole value chain of the design and adaptation of the built environment. Whether you are at the stage where you're evaluating a site and just want to understand what would happen if I put here, let's say, 400,000 square meters of residential mass. And then it's at the developers stage where you're just essentially evaluating the site, right? So you can run potential scenarios and see how that affect the sort of like conditions. What can happen there is you can get sort of like generalized metrics of how much that massing would affect that environment, and what things you should be more careful about, like let's say your height ratio to density, or other things that are more on the beginning of the early stage. At the design stage, we want to be able to offer to every designer, every planner, not only on the sort of like urban scale, but also on the interior of buildings, how does your design perform? So essentially giving you metrics, more generalized as well as like detailed metrics on every room, every area, external area. How does it work with the climate? And then even at the stage where the property is sold or evaluated, to be able to just very quickly evaluate the property, as well as existing structures, existing constructions, and how you can adapt them. So eventually what we want to do is be able to give insight on all of these stages and recommendations. And what you were saying was exactly that, essentially giving specific recommendations to users. Maybe you have too much open windows on the north side of your building. Perhaps you want to close a little bit the openings.
Okay, I see. Very fascinating. And you mentioned your clients earlier, at least your potential clients. Could you tell me what areas or what regions or cities could we expect city planning helped by infrared city in the future?
Yeah, for sure. Infrared city, I mean, infrared models, like AI models, some of them, or most of them are like global. They don't really, they're like not location specific. Like for example, wind simulations, you can do it in all around the world. Some of them would be like city specific, which means that for those ones, we'd have to start with a few key cities in the world, and then we will expand. We would, of course, depending on the clients, we can actually train models very fast, depending on sort of like what clients needs in terms of like new cities. But generally, we want to have a global access. We're not restricted in a specific geographic area. And in terms of like, as I said, the clients, who are they? The professionals that would be benefiting from that. It is anyone who is in the architecture, engineering, construction industry and needs to understand the interaction of buildings with the climate.
I see. Okay. Well, that sounds all very promising. So, what future plans does Infrared City have? What do you accomplish in the long run in the next, say, 5 years or so?
Yeah, so we truly hope to be a lighthouse project for essentially removing the barriers of simulation. So we really want to be able, let's say in 5 years, which is not very far away, but also not very close, to be able to give insight on the designs and adaptation and new constructions of any place in the world. And essentially, you need to be able to point a point in the world, give us a model or a plan, and we are able to tell you enough about how your urban environment will operate in relation to the climate. And I think that's, for us, the most interesting thing is we design, and we've been doing this for many years with our co-founders, we're designing for today, right? So essentially, when we look at a property, or when we look at a house, right, or at a building, or at the public space, we're looking at, let's say, 30 years of statistics of statistical data of the climate, and we say, according to this average climate of this area, this is how this place will perform. What we really believe we should do, and we're actually planning to develop with Infrared, is look at the future, because that square, that flat, that sort of like big building will not perform the same way in 2050. It will be radically different, and the future climate will have to show us essentially how the built environment will perform then. So we have to be able to show that to users, and with that they're able to make decisions. And essentially, in this case, we are actually changing the value of urban assets by instilling the climate impact in them, and that is our biggest vision.
Okay, well, I wish you good luck with that because it sounds very important for the world at large. Thank you so much for joining us today. Thank you, Angelos.
Thank you. It was a pleasure.
So, this was Angelos Chronis of Infrared City. And with that, we have reached the end of this podcast episode. Thank you for listening and tune in next time when we once again welcome exciting guests into our podcast. Bye!